Hello everyone, Matt Claxon here with part 2 of our Emerging Technologies assignment. I wanted to start off this particular assignment with exploring computer science in the classroom. Something I've thought about for a long time, something I wanted to do. As I started to research, I saw the need in that it is something that is an emerging technology. It's not a new idea. Over 40 years ago, people were recommending that we use programming to teach algebra. In 2013, things started to take off as far as education was concerned, with an advocacy group that code.org advocacy. This is their landing page. They're very involved. Their founders felt it was really important for educators and students alike to explore coding as an option. When I thought back to my experience, Texas Instruments is that's how I was introduced to coding in math class with TI 83 Plus calculator. My teacher, Mrs. Troyer, allowed us to use a program on our quiz or test if we were the ones who created it. There were some issues with students just copying the programming language. I've tried to think about creative ways to explore that option in my classroom as well. Maybe if a student can explain how they created the program. It is kind of tough to do and tough to police, if you will. We have Khan Academy if you're short on time. Their hour of code, which that hour of code is trademarked by that code.org. But you have options there. If you click on the teacher option, it gives you a really good introduction just in as far as what the hour of coding is. Looking back here, that's that advocacy coalition, the code.org. They are responsible for that hour of code, the one that started in 2013. The one that I actually chose to demonstrate in this emerging technology is Scratch code. Scratch code can be used, kindergartners all the way through college students can use this Scratch code. I'm really interested in it now, and I want to show it to you. Some general definitions for coding are listed below. I got these from an article titled 5 Reasons Your Child Should Learn to Code. That was from a biased source as EDTL. They are a company that hosts camps for technology out in California. So, but there was some pertinent information anyway to share with you. If you want to implement code in the math classroom, why? Well, it does help students to solve problems. It applies to our high standards of mathematical practice in algebra and geometry, right? They're the same for all math subjects for the standards of mathematical practice. In addition to that, it's fun, and it helps students see the relevance of math. It's something that's tangible. Something that really got me interested in this coding was the code.org advocacy group. I teach algebra, so this particular slide right here, this particular website that says computer science and algebra, they created this language, programming language, Bootstrap, which behaves very similar to mathematics as far as the definitions are concerned. And that's not always the case when it comes to coding. Not all coding languages behave like the math logic that we're used to. So they developed this one specifically for math classes. You can see all the curriculum documents that they have. I found the student workbook. They make several references to that. That's where the worksheets are, and the teacher manual to be very helpful. You can see just how popular this code.org, this advocacy coalition is. Really popular. They've got Plenty of videos here if you would want to sort through it. Getting back to what I'm interested in that algebra piece, the geometry piece, there aren't as many curriculum documents, but you can do a search for different projects within that they have within the high school curriculum. In searching for these projects, I found it helpful to go to the most popular and look for and check lesson plans. And then we have math selected as well. There are other ways to sort this by, what classroom technology you have. For the ice cream machine, I know it's grades 6 plus, but it does apply to the math standards. If you look at the Ohio math standards, we've got a critical area of focus here, connecting algebra and geometry through coordinates, and that's what that particular project does. In addition to that, we're going to use volume formulas for cylinders, pyramids, cones, and spheres to solve problems. And you have all those mathematical practice standards as well, which, coding really does help students to apply what they've learned. Moving on here, if you're going to implement Scratch code in particular, so I'm switching lanes here now. I am moving to Scratch. Scratch is what I decided to explore here because I wanted to do something earlier on in the year, and they had a name animation project or lesson, if you will, that really I think will be a good intro to coding in the classroom. But what do they recommend? They recommend about 10 minutes of, using the imagination, brainstorming, allow students time to explore and create for 40 minutes, and then share for 10 minutes. Let's go ahead and look at that landing page. Landing page for Scratch. Well, if you go to landing page, you see all the different options that you have to explore. If you allow students to explore this, they will probably come up with more examples and applications than you would be able to get in 5 minutes, especially if they put their heads together. I like to click on the ideas tab there. It does give you the option to choose a tutorial. Again, they do want you to interact with it right away. I went down to the animate a name. I clicked on that, and then the educator guide. I downloaded that PDF. So when I downloaded that PDF, or it opened up as a new link there, it did give me all these different the explanation of just how to create the animation and the different options that I have. There are also flashcards, the activity cards, which, going to this link right here allows you to print those cards off. Those are really helpful if you're doing groups. Then you can put one of those cards at each group, have students rotate after 5 minutes or so, so they can kind of go through and learn it as a group together. It wouldn't be a bad idea. Looking at the the About Scratch offers some neat videos and things to interact with. I'm a big fan of TED videos. We have just the math projects, and I had to do a search for this. I didn't do a Google search to get here, actually, but you see all the possibilities here, and that it's not just for elementary education. The Scratch for Educators, that's where I started to find some good resources. When I did click on resources, I saw the resources for educators. Now, we've explored already the educator guides, but it does have some creative computing. So there's this, Harvard has some plans and activities that you can follow. for the Scratch curriculum as well. They've got a really good graduate program for teaching computer science in the classroom. So this is popular. There are some prominent universities and people that are donating to the cause, if you will. Millions of dollars are being donated by Facebook and Google, Microsoft, because people see the value in coding. I'll go ahead and show you the project that I created now. It's our mascot. Our mascot, we are the Quakers, so I decided just to create that name instead of my own name, Matt. I may do another one for my students, not sure. So the vocabulary is really important, actually, to go over with students ahead of time. I've created some slides here to just kind of, I'll flip through some of the vocabulary options here. We've got the Scratch. Blocks are the commands. We've got a project, and that's just when you finish. The stage is where your project is displayed. Scripts, and the one I really wanted to get to was number 6, the sprite. The sprite is the actual object that will perform actions there. So if we go back to our Scratch project here, you see that each of these letters, that's a sprite. So when I click on the Q, I had to first select an event for this. This flag is like the go button. It's like a play button, if you will. I just selected when the sprite is clicked. It will play a sound. I actually got to record my own voice saying Q. It was a very intuitive process. I then changed the size. I dilate it, if you will. There's a geometry term. I'll wait for half a second and then dilate it back. So when I click the Q, you can't hear it, but it does say Q, it dilates, and it goes back. Looking at the U, I did the same thing. One reason I was able to do the same thing here is because I've discovered this backpack. Once you find a command that works really well, you can drag it down here to your backpack. You do have to separate it first. It's a learning experience, and then drag it all the way down in there to the backpack and release it. So that would have been really helpful for me to find early on in the process. But you can see the different animations that happen here in the tutorial. If you forget, you can just click on tutorial within this and click on animate a name. And this is really helpful because this tutorial stays up while you're actually, while you're able to load the commands on here. This tutorial stays up. It's really very useful. They have a video there, but this makes it a lot easier to do. My favorite features were the backpack. In addition to the backpack, you know, that tutorial feature I found was very helpful as well. So you can see the project. I'll link to it so everyone can play around with it and get to experience, you know, just what happens when as I click on each letter. I did provide some different animations down here at the end, so I'm excited for you to take a look at it. Thank you very much for listening today, and I hope that you see the value of computer science in math education.